Hello everybody, I hope you're all doing well, feeling fine, and ready for question 19 on our grade 8 Gauss paper. A line segment joins points P at negative 4, 1 and Q at 1, negative 11. What is the length of PQ? Okay, there's a couple ways to do this. If you're familiar with points on grids, you might know something called the Euclidean distance formula, which just sort of tells you, okay, you put in each of the coordinates, do the calculation, and you get the length of the line segment joining them. Okay? Now, if you haven't seen it before, I'm going to sort of teach it to you really quickly as we do this question. So negative 4 and 1 is where P is, somewhere around here. And then Q is at 1, negative 11, so way down here. Okay? Now we want this line segment. Well, it's kind of hard to tell, but what we can do is we can drop a nice little right angle triangle down here. Okay? So just like the coordinate axes, these are perpendicular. And so this point down here at the 90 degree is right below P. Okay? And it's right across from Q. So its x coordinate, it's exactly as far left as P is. It must be negative 4, and it's down exactly as far as Q is, so its its y coordinate is negative 11. Okay? Now, how does this help us? Well, we've got a nice little right angle triangle. We know using the Pythagorean theorem how to get the length of the hypotenuse in terms of the lengths of the legs, and now that we've got this point, we can say, okay, to get from 1 down to negative 11, you have to go a distance of 12. So if we call this point R, PR is 12. If I'm at 1, how far do I have to go to get to negative 4? I have to go back 5 spaces. So what we're looking at here is a right angle triangle. PQ is the hypotenuse. So now we just say, okay, well, PQ squared is 5 squared plus 12 squared. And if you're familiar with Pythagorean triples, and I do always encourage you to be familiar with the first few Pythagorean triples, you might recognize this as the 5, 12, 13 triangle. If not, of course, we can grab our calculators and take the square root of 169, which is 13. And so that's going to be an answer of A. Okay? Now, this technique can be applied more generally. And if I've got a point up here with coordinates x1, y1, and I've got another point down here with coordinates x2, y2, we can do the same sort of right angle triangle trick. You can actually get a formula for the distance between any 2 points. So I'll leave you with this. It's a nice little thing to have around. It's the difference in the x coordinates squared. Doesn't matter which one, do x1 minus x2 or x2 minus x1, because you're just going to square it, so it doesn't matter. And then the difference in the y coordinates squared. And so if you memorize this formula, this question wouldn't be any trouble at all. And even if you don't have that memorized, it's very easy to reproduce the nice little right angles here to get us our answer. Okay, so answer for question number 19 was A, and we move right on to question number 20.